When the Second World War began in 1939, German armor was the cutting edge of battlefield innovation. The panzer divisions that rolled into Poland and France embodied a new kind of war, blitzkrieg. Fast, coordinated, terrifying, the Panzer III and Abwehr, with their sharp angles and precision-engineered components, became the backbone of this lightning advance. Each machine was crafted like a weapon of art, tuned to perfection, tested to extremes. The Wehrmacht believed that mastery lay in mechanical excellence, in engineering superiority. Their tanks reflected that belief, powerful but complex. Across the Atlantic, America watched the storm unfold. The U.S. Army's tank forces were small, its doctrines untested. But by 1941, with war spreading across continents, the United States faced an urgent truth. To fight globally, it needed machines that could be built fast, shipped anywhere, and run under any condition. That truth shaped the birth of the M4 Sherman. Unlike German armor, which was designed for precision and performance, the Sherman was designed for endurance. It wasn't meant to dominate a duel. It was meant to last the war. Engineers in Detroit and Chicago didn't chase perfection. They chased reliability. The M4 had standardized components, a dependable Continental radial engine, and an ingenious suspension system that could be repaired in the field with simple tools. Crews could learn to operate it in days, not months. To the German eye, that was sacrilege. German engineering culture prided itself on refinement, layers of intricate systems, tight tolerances, and complex mechanics. Tanks like the Tiger were monuments to mechanical ambition. 60 tons of steel, thick armor, an 88mm cannon that could destroy any Allied tank at over a mile. Yet beneath that power lay fragility. A Tiger could break down after just a few hours of operation. It needed special transporters, special parts, and constant attention. The Sherman was the opposite. It was the soldier's tank, not a masterpiece, but a mule. It could cross rivers, plow through mud, and keep moving with bullet holes in its hull. When American forces landed in North Africa in 1942, the Germans met the Sherman for the first time. At first glance, it seemed unimpressive. Its armor wasn't exceptional. Its gun looked small. Its silhouette was tall and awkward. But in battle, the Germans began to notice something disturbing. No matter how many Shermans they destroyed, more kept coming. It was not just quantity. It was consistency. Each Sherman performed the same. Each could be repaired using interchangeable parts. Each crew knew their controls, their systems, their engine sounds. What the Germans saw as simplicity was in truth a new kind of power. By 1943, the war had changed. The German advance in the east had stalled. The vast distances of Russia exposed their machines' weaknesses, cold weather, dust, and overworked transmissions. Meanwhile, the Allies, backed by factories running day and night, were producing tanks faster than the Germans could destroy them. The Wehrmacht's command staff grew increasingly curious. Reports from the front lines described captured American tanks still running after weeks of abuse, while their own high-performance models sat immobile in the mud. In late 1943, after the battles in Tunisia, several Sherman tanks were captured almost intact. Among them were M4A1 and M4A2 variants, machines that had survived artillery fire, air attack, and retreating sabotage. They were shipped back to Germany for study. To the engineers, this was an opportunity. The Allies had revealed their mechanical philosophy, and now the Germans would dissect it piece by piece. At the testing grounds of Kummersdorf, near Berlin and Eisenach in Thuringia, these captured Shermans arrived by rail under heavy guard. Technicians rolled them into hangars beside the latest German designs, the Panther, the Tiger, the Elephant. On the surface, the Sherman looked crude compared to these giants. But the German engineers were trained to see deeper, to find patterns, to measure endurance. They didn't yet know it, but what they were about to test would challenge the very foundation of their design beliefs. Because inside that simple hull, the Americans had hidden something Germany's war machine had never mastered: the art of reliability under chaos. And as the first set of tools clanked against the Sherman's armor, the Germans began their meticulous inspection. The journey of the captured Shermans across occupied Europe was unlike any other. These were not trophies of war paraded for propaganda. They were specimens. Each tank represented a puzzle the German High Command wanted solved. How did the Allies make machines that simply refused to die? In early 1944, at least 3 operational M4 Shermans were recovered in Tunisia and southern Italy, where intact examples had been abandoned after running out of fuel. Others were captured in Normandy and sent east for evaluation. The most famous of these ended up at Kummersdorf, the nerve center of Germany's secret weapons testing program. Kummersdorf was no ordinary facility. Hidden among pine forests and frozen fields south of Berlin, it had served since the First World War as the Reich's principal proving ground. Here the first German tanks had been tested in violation of the Treaty of Versailles. Here the earliest jet engines and rockets were quietly assembled. And now in the winter of 1943-44, it was where engineers of the Heereswaffenamt, the German Army Weapons Office, would scrutinize the American Sherman. The tank arrived on a flatbed train. Its olive paint was dull, its hull scarred by shrapnel. Yet when mechanics refueled it and primed the starter, the radial engine came alive instantly, to the surprise of everyone present. The German officers in attendance noted in their report that the foreign motor exhibits unusual tolerance to cold weather and neglect. The tests began systematically. First, they measured weight distribution and armor composition. The Sherman's armor was cast, not welded, a choice that puzzled the Germans at first. To them, cast armor seemed crude and imprecise, but the metallurgical analysis revealed something unexpected. The casting gave the hull structural integrity and saved production time. It was faster, simpler, and strong enough to survive most hits from medium-caliber guns. Then came the inspection of internal design. German engineers removed panels, opened hatches, and studied the interior layout. The findings were almost insulting to their engineering pride. The inside of the Sherman was simple, no unnecessary systems, no intricate mechanisms. The wiring was organized, labeled accessible. Spare tools were mounted in reach of the crew. The report noted, maintenance tasks can be performed by common soldiers without technical schooling. That line, buried deep in an engineer's handwritten notes, spoke volumes. It captured the gulf between German and Allied philosophy. German tanks demanded trained specialists. The Sherman demanded only willpower and a wrench. The power plant itself fascinated them. Most German tanks relied on Maybach engines, powerful but notoriously delicate. The Sherman's Continental R975 radial engine, originally an aircraft design, seemed almost agricultural by comparison. It ran hot, loud, and with minimal refinement. But it ran always. Even after deliberate stress tests, oil contamination, extended idling, and repeated cold starts, it refused to fail. Kummersdorf's technical report remarked on this bluntly. This motor tolerates mistreatment which would be unthinkable in German designs. The suspension trials came next. The Sherman's vertical volute spring suspension, VVSS, looked primitive to the Germans, but on the proving ground, it astonished them. Over rocky terrain and mud pits, it kept the tank stable and steady. Crews riding inside described a smoother motion than even the Panther could manage. And when they deliberately damaged a bogie unit, they replaced it within an hour, using only hand tools. By contrast, a damaged Tiger or Panther suspension could immobilize the entire vehicle for days. The more the Germans tested, the more their confusion deepened. This machine was not exceptional in any one area, not the fastest nor the most heavily armored. Yet it excelled in a quality that Germany's industrial system had never prioritized: recoverability. A Sherman could be built quickly, repaired quickly, and returned to battle again. Its parts were modular, its design standardized across thousands of units. The engineers realized something profound, that the Sherman's strength was not in its steel, but in its philosophy. It was a tank built to serve an army, not an ego. As the winter sun set over Kummersdorf, one senior officer reportedly remarked that if Germany had possessed such simplicity in its designs, its armies might have been unstoppable. The tests, however, were only beginning. What came next would move beyond technical admiration into reluctant respect. Because when the Germans took the Sherman into full operational trials, driving it under live fire and extreme stress, they began to see something even they couldn't deny. The Sherman might not have been beautiful, but it was built to endure war itself. At Kummersdorf, every evaluation followed a methodical rhythm. Each department, mechanical, tactical, and ergonomic, examined the captured Sherman through its own lens. But the more they studied it, the more one unsettling theme kept returning. The Americans had built for victory, not vanity. German engineers were taught from their earliest apprenticeships that a machine was a reflection of its maker's intellect. A Panther tank represented mastery, a symphony of interlocking systems, finely balanced and tuned to the limits of metallurgy. The Sherman, by comparison, looked crude. Bolted plates, simple hydraulics, basic optics. Yet in this supposed crudity lay brilliance. The Germans discovered that every part of the Sherman was designed with the battlefield in mind. Its components were standardized across factories. Its gearbox could fit multiple engine variants. Its armor castings followed repeatable molds that allowed dozens of contractors to produce identical hulls simultaneously. One Kummersdorf memorandum noted with subdued admiration, "The Americans have succeeded in industrially organizing tank manufacture as we have organized the building of rifles." It was an inversion of priorities. Germany had built a few masterpieces. The Allies had built an army. When German officers first entered the Sherman's interior, they were struck by its space. Compared to the cramped conditions inside a Panzer IV or Panther, the American design felt almost generous. The driver and gunner had legroom. The hatches were wide and easy to operate. This was not luxury, it was functionality. The Allies understood that fatigue killed more crews than bullets. A comfortable crew fought longer, aimed steadier, reacted faster. German tankers, by contrast, often suffered exhaustion and heat stress inside their tight steel boxes. The Sherman's layout also prioritized escape routes. Each crewman had quick access to a hatch. German tanks, with narrow exits and complex locking systems, often became death traps when hit. During testing, the Germans simulated internal fires using smoke charges. They timed the evacuation of crews. The Sherman's design allowed its operators to exit in seconds, a detail that deeply impressed the observers. One report concluded with unusual candor. "Enemy tank prioritizes crew survival to a degree uncommon in German design." That simple line revealed an unspoken truth. The Sherman was built for the human inside it, not just the war around it. Perhaps the greatest revelation at Kummersdorf came not from the tank's armor or gun, but from its simplicity of maintenance. German engineers examined the way the Sherman's systems could be replaced. The powertrain could be pulled out with basic lifting gear. The filters, wiring, and suspension were modular. Each part was labeled with standardized serial numbers. One observer remarked, "This tank is not built to last forever. It is built to be repaired forever." That insight struck at the heart of Germany's wartime problem. By 1944, the Reich's production lines were fragmented by Allied bombing. Each Panzer factory built slightly different versions, incompatible components, complex supply chains, constant shortages. The Americans, however, had done something extraordinary. They had turned tank building into assembly line warfare. A damaged Sherman in Normandy could receive replacement parts built in Michigan, assembled in Britain, and shipped across the Channel, all without adjustment. This logistical genius terrified the Germans more than any new gun or armor design. It meant that while their tanks were masterpieces, the Allied tanks were inevitable. Finally came the field tests. Engineers drove the Sherman for hours across the rough terrain surrounding Kummersdorf. They pushed it through frozen puddles, mud fields, and inclines meant to immobilize lesser vehicles. To their astonishment, the American tank performed with quiet determination. It was not the fastest nor the smoothest, but it never stopped. The Panther, when tested under similar conditions, often overheated or broke a track. The Tiger struggled with fuel consumption, devouring over 500 liters per 100 kilometers. The Sherman consumed roughly half, and kept running even when underpowered. The Germans conducted deliberate abuse tests, contaminated oil, delayed maintenance, extreme cold starts. The Sherman endured it all. Its secret was not superior materials, but tolerance. Every bearing, bolt, and piston was designed with wider operational margins. It didn't require precision assembly to function. It only needed fuel and a crew. To an engineer raised on the creed of perfection, this was heresy. But to a soldier, it was salvation. In one internal summary dated early 1944, the verdict read, American design accepts imperfection for the sake of continuity. We have sought perfection and found paralysis. That sentence circulated quietly among Germany's technical staff, a reluctant acknowledgement that the Sherman's true weapon was not firepower, but philosophy, and yet not every German was convinced. The Waffenamt's Armored Warfare Department demanded harder data, gunnery, armor penetration, real combat performance. They wanted to see whether this practical machine could survive German fire. The next phase of testing would push the Sherman into the crucible, under live shells, over live ground. That's where admiration would turn into respect. The first round of technical evaluations had humbled many of the German engineers. Yet one question still remained. Could this American machine truly stand against German firepower? For all its reliability, the Sherman carried a 75mm gun, and in the world of German armor, that was almost modest. The real test, they said, would come at the firing range. At Kummersdorf South Range, a Sherman hull was positioned against a battery of German anti-tank weapons. The 50mm Pak 38, the 75mm Pak 40, and finally the Tiger's 88mm KWK 36, each weapon fired at measured distances to test the Sherman's armor angles and resistance. The results were predictable. The 80mm tore through it effortlessly, and even the 75mm could penetrate the glacis at shorter ranges. German officers watched the test with satisfaction. Their guns remained superior. But what came next intrigued them more than the armor itself. When the Sherman fired back, its stabilized 75mm M3 gun, primitive by German standards, achieved a surprising consistency. Even while moving at moderate speed, it struck targets within its range effectively. The Germans realized the secret lay not in power, but in stabilization. The Sherman's vertical gun stabilizer allowed crews to fire with accuracy on the move, a concept that German tanks lacked entirely. The Tiger and Panther had superior optics and guns, but they required the vehicle to stop before aiming precisely. The Sherman could fire first, and in tank combat, the first hit often decided survival. German gunnery officers noted, "This stabilizing mechanism, though simple, provides a tactical advantage in fluid combat." That quiet acknowledgement, buried deep in technical notes, marked the first time German evaluators openly admired an American fire control innovation. They understood then that the Sherman was not built for duels. It was built for momentum. The Americans had designed a tank that didn't need to win every fight, only to keep fighting. By mid-1944, the Sherman existed in dozens of variants. Flamethrower versions, amphibious duplex drive tanks, the Sherman Firefly, mounting a British 17-pounder gun, capable of destroying a Tiger at range. The Germans, analyzing these variants, were astonished by the flexibility of the base chassis. It was as if the Americans had designed one universal tank that could be modified to suit every battlefield, from the deserts of North Africa to the hedgerows of Normandy and the jungles of the Pacific. In contrast, German tanks were highly specialized. The Tiger was designed for frontal engagements on open terrain, the Panther for mid-range duels. Neither adapted well to different environments. German reports from the Versuchsabteilung für Panzerentwicklung, Tank Development Experimental Unit observed, the American design displays a remarkable capacity for modification without structural compromise. Their system favors adaptability over specialization. This adaptability was not just a technical achievement, it was a strategic one. It meant that Allied logistics could ship any Sherman to any theater, confident it would perform. It also meant that upgrades could be applied universally. A new radio, gun, or armor plate developed in 1944 could be installed across thousands of tanks with minimal alteration. Germany, with its fragmented design network, could never achieve that. Every new tank model required new tools, new parts, new training. By the time the Allies landed in Normandy, the Sherman's adaptability had become a silent weapon. Amphibious Shermans led the first waves onto the beaches. Fireflies waited inland for Tiger counterattacks. The machine Germany had once dismissed as inferior had evolved into an army of shapes and roles, all sharing the same mechanical soul. To the German testers, this was perhaps the most sobering revelation. The Sherman was not just a tank, it was a system, a foundation that could grow as the war changed. The deeper the test went, the quieter the engineers became. For years, they had believed that technical superiority guaranteed victory. Now standing beside a battered American tank that refused to fail, that faith began to waver. One engineer interviewed after the war recalled the mood. It was humiliating in a way. We built machines of genius, but they could not endure a soldier's war. The Sherman represented a different kind of genius, one rooted in restraint. The Americans had deliberately accepted limitations: thinner armor, a smaller gun, moderate speed. Yet through those compromises came balance, reliability, and scalability, the very qualities Germany's perfectionism had sacrificed. The Germans had pursued dominance. The Allies had pursued function. At Kummersdorf, as the Sherman's engine roared through yet another endurance test, that realization sank in. This tank had been built by a nation of manufacturers, not artisans, but it was precisely that industrial mindset that made it unstoppable. Reports began to circulate among technical officers. They contained reluctant words of admiration. This design philosophy cannot be easily imitated under current wartime conditions. In other words, it was too late. Germany could not rebuild its industry, retrain its engineers, and redesign its tanks to match the Sherman's simplicity. The war had moved past them. As the months went on, the engineers returned to their regular work, perfecting the Panther II, sketching concepts for the massive E-series tanks. But something had changed in their hearts. They had seen a machine that embodied everything their own industry could not become. The Sherman was not beautiful. It was not elegant, but it worked. And for men who had devoted their lives to perfecting the art of machinery, that was the hardest truth of all. By early 1944, the Kummersdorf tests had reached their conclusion. The German engineers had gathered their data, filed their reports, and handed them to the Waffenamt. But the lessons they learned there, quietly, reluctantly, would echo long after the war ended. The next chapter in this story begins when those same engineers put the Sherman against their own creations in direct comparative trials that revealed the raw, painful truth of Germany's armored reality. The morning of the comparative trials was cold and overcast. At the Kummersdorf proving grounds, a Panther tank stood beside the captured Sherman, both engines idling, exhausts sending gray columns into the winter air. Behind them, a Tiger waited under a canvas tarp, its immense gun elevated like a silent threat. The objective was simple: a full operational evaluation. Performance, mobility, reliability. A contest between philosophy and pride. The German engineers divided into two groups. One oversaw their own tanks. The other was assigned to the American. Each team carried stopwatches, fuel gauges, and log sheets. At precisely 090, the trial began. The Panther surged forward first, its Maybach engine roaring with controlled fury. It tore down the dirt path, treads biting into the frozen ground. Its power was undeniable. Until within 15 minutes, the transmission temperature rose beyond safe limits. Mechanics signaled a halt. Steam hissed through the side vents. A minor leak, but enough to stop the run. Then the Sherman moved. Its engine was loud, uneven, almost agricultural, but steady. It rolled across the same track with a kind of stubborn grace. The engineers recorded every kilometer, 10, 20, 30, still running. The radial motor rattled, coughed smoke, then settled again, as if unfazed by the cold. At the 50-kilometer mark, one of the technicians remarked that they had not stopped once. The driver smiled beneath his goggles. "She keeps going," he said quietly. The Panther's crew standing nearby exchanged looks, half disbelief, half irritation. When the Tiger I's turn came, its presence dominated the field. The sound of its 88mm gun echoing off its heavy turret was unmistakable, a reminder of why Allied soldiers feared it. But when it began its mobility test, problems appeared immediately. The Tiger was a marvel of engineering, yet its weight was its curse. It tore deep ruts in the earth, struggled on inclines, and devoured fuel at an astonishing rate. By the time it reached 20 kilometers, it had already consumed nearly half its fuel reserves. The Sherman, having completed the same course, had used barely a third. The engineers took notes. their handwriting growing smaller and quieter with each comparison. At noon, the trials moved to the mud field, a section of terrain deliberately soaked to simulate the conditions of the Eastern Front. This was where even German tanks dreaded to tread. The Panther entered first. It made it halfway before its tracks jammed with heavy clay. The Tiger followed, powerful but sluggish. Its great weight turned the soft ground into a trap. Then came the Sherman. It entered the pit slowly, its suspension flexing rhythmically. The vertical volute spring suspension, that simple American innovation, absorbed the uneven terrain like a living organism. The tank rocked but never bogged down. It clawed forward, climbing out of the pit with its engine humming steadily. A German engineer standing beside his clipboard said under his breath, "Unglaublich." Unbelievable. It wasn't speed that impressed them. It was endurance. Throughout the afternoon, the Sherman performed task after task, hill climbs, braking tests, cross-country runs, with a kind of effortless persistence. Its parts rattled and groaned, but nothing broke. By contrast, the Panther required constant attention. Mechanics swarmed it between runs, adjusting belts, draining oil, tightening fittings. The Tiger's engineers wrestled with its overcomplicated steering system, logging yet another delay. As dusk approached, the results became undeniable. The German tanks, though magnificent, were fragile racehorses. The Sherman was a workhorse, flawed, loud, but tireless. When the day ended, the engineers gathered in the observation shed, their tables covered with notes and fuel charts. One of them, a veteran designer from MAN, stared at the data for a long time before speaking. "They built for soldiers," he said quietly. "We built for engineers." It was not an official conclusion, but everyone in the room understood it as one. That night, long after the tests ended, a few officers stayed behind. They stood outside the hangar where the Sherman was parked. Its engine still clicked faintly as it cooled, a mechanical heartbeat that seemed to defy silence itself. In the distance, the Tiger loomed under its tarp, a monument to Germany's ambition. But beside it, the Sherman looked alive, imperfect, scarred but alive. For the first time, the Germans began to see that reliability could be its own kind of power. A quiet, relentless power that might outlast even the most perfect machine. The trials were not over. The next phase would involve live-fire endurance, a brutal test of how much punishment the Sherman could take before breaking. And it was during that stage, under explosions and recoil, that the German engineers finally admitted a truth they had resisted from the start. The following morning, the snow had melted into a thin, gray slush. Over the proving ground, black smoke hung low from the test range, the field where captured tanks met their final trial. Destruction. This was not a test of beauty or speed anymore. It was a test of survival. A new Sherman, towed from the captured vehicle's yard, was positioned at the center of the range. Its olive paint was faded, its markings still bearing the white star of the U.S. Army. Around it stood a team of German officers, engineers, and gunners. Their orders were simple: push it until it fails. The first phase was endurance under strain. The engine was run continuously for 6 hours at varied throttle, simulating prolonged battlefield use. The Panther, tested earlier, had seized at 4. The Tiger's clutch had burned out after 5. The Sherman, though coughing smoke and shaking violently at times, kept running. Mechanics logged every minute. Oil temperature stable. Coolant pressure holding. Exhaust fumes thickened, but the machine did not stop. Then came the live fire test. A 50mm anti-tank gun was brought forward, the same weapon that had once been deadly to early Allied armor. The first shell struck the Sherman's side plate. A sharp metallic thud echoed across the range. The armor dented but did not breach. The second round hit lower, near the suspension. One bogie snapped. The track twisted, but the hull remained intact. German officers exchanged notes. They were impressed but not convinced. "Use the 75, one said. The larger gun barked once, and this time the shell pierced clean through the flank, exiting in a burst of smoke. The test crew advanced carefully. The engine was still idling. Even holed and crippled, the Sherman's motor refused to die. An engineer recorded in the logbook, "Motor continues to operate despite penetration. Fuel system appears undamaged. Remarkable resilience." They decided to push harder. A Tiger I was rolled forward. Its 88-meter gun aligned at 800 meters. A shell screamed through the air and tore into the Sherman's front glacis. The tank shuddered, its turret jarred sideways, the sound of splintering steel echoing through the cold. When the smoke cleared, the upper hull was mangled, but the interior still hadn't ignited. No catastrophic detonation, no ammo cook-off. That surprised everyone. The Sherman's fuel system, criticized by many, had been sealed and baffled so well that even a massive penetration hadn't caused the fire they expected. One officer muttered, "If this had been a T-34, it would have burned." Another added quietly, "They build for men, not museums." They continued the barrage until the machine was little more than a smoking carcass. And yet, when the test ended, one engineer climbed up the hull, opened the hatch, and the smell of hot oil, not burning fuel, met him. He wrote in his report, "This tank is crude, but it endures damage far beyond its intended limits. The simplicity of its systems allows continued function after severe impairment." When the day ended, the Sherman was nothing but twisted steel. But the idea of it, the philosophy behind its design, now lived in the notebooks of the very men who had once mocked it. That night, in the officers' mess, the engineers gathered for a debriefing. Charts and photographs covered the tables, penetration patterns, failure diagrams, performance graphs. The head of the testing division, Oberstleutnant Karl Tomala, listened as his subordinates presented their conclusions. One spoke first. "The Panther is superior in firepower and armor, but cannot endure prolonged field use without extensive maintenance." Another added, "The Tiger demonstrates overwhelming strength, but at the cost of mobility and practicality. It cannot be mass-produced without crippling logistics." Finally, a young engineer stood and read from his notes about the American machine. "The Sherman lacks refinement and sophistication. Its armor is insufficient against heavy guns, yet its reliability, maintainability, and endurance under stress are extraordinary. It can be repaired in the field with minimal tools. This, above all, is the reason it prevails." The room fell silent. Outside, the wind howled softly against the walls. Tomale closed the folder in front of him. He had spent years designing complex, elegant tanks, machines meant to embody German precision. But now, staring at the data, he felt something shift inside him. They had built for perfection. The Americans had built for war, he finally said. The true strength of a weapon lies not in its complexity, but in how easily it can be fought with. Fixed and fought again, no one argued. The report sent to Berlin in early March 1944 was cautiously worded. The Wehrmacht rarely admitted admiration for enemy equipment, but the truth was there between the lines. It stated, U.S. Sherman tank demonstrates exceptional operational reliability. Despite inferior protection and armament, its mechanical endurance and ease of service make it a formidable battlefield vehicle. Weeks later, one of those engineers, reassigned to the Eastern Front, saw Shermans again, this time through the smoke of battle bearing Soviet stars under Lend-Lease. They came rumbling through the mud, engines howling just as they had in Kummersdorf, and he realized with grim certainty that those same traits he had tested were now the reason they kept advancing. Machines that didn't break, armies that didn't stop. In that moment, admiration turned to dread. The war had become a contest not of brilliance, but of endurance, and endurance was a race the Germans were no longer winning. By the spring of 1944, the German Testing Command had finished its official report on the captured American tank. The final document, signed and archived under Versuchsbericht number 186 of 44, summarized what the engineers had seen with their own eyes at Kummersdorf and Eisenach. The M4 is a weapon of endurance, not brilliance. Its value lies in the simplicity of its systems and the reliability of its powertrain. While tactically inferior in single combat to the Panther or Tiger, it possesses an unmatched logistical advantage. It was a quiet admission, but a profound one. For years, German engineering had followed the path of excellence at all costs. Their tanks were machines of precision, each part designed to exact tolerances, but that perfection was fragile. Every kilometer driven required attention, spare parts, trained mechanics. The Sherman had no such demands. Its systems were modular. Its parts were interchangeable. It could be repaired by any crew with a wrench and determination. The Allies had traded elegance for practicality, and as the war turned against Germany, the trade had proven decisive. The lessons from the tests circulated among officers in the Panzerwaffe, but few had the time or freedom to act on them. The Reich's industry was collapsing under constant bombing. Raw materials were scarce and fuel was rationed. Factories that once built precision machinery were now in ruins. Even so, engineers began to take notes for the future. They studied how the Sherman's suspension endured long marches, how its air-cooled engines ran without overheating in desert heat or Russian frost, how its transmissions were easily replaced. When Allied forces finally entered Germany in 1945, they discovered those same reports still stacked in the archives, covered in dust but filled with admiration for the enemy's design philosophy. At that time, in the rubble of Berlin, German tank designers were already dreaming of the next generation, machines that would combine firepower with the reliability they had once dismissed. The irony was that the Allies, too, were learning from them. The Panther's sloped armor, its stabilized gun sight, its efficient high-velocity cannon, all these elements would influence the future of Western tanks, just as the Sherman's reliability would inspire the engineering principles behind them. The war had been a crucible. Both sides had seen the limits of their philosophies. In the months after Germany's defeat, the surviving engineers of Kummersdorf were quietly interviewed by Allied technical missions. Among them was Karl Tomale, the officer who had signed off the Sherman's final test results. He spoke candidly about the experience. His words were recorded by the U.S. Army's Technical Intelligence Service. Our tanks were made for victory parades, not for endless battlefields. The American tank was made for soldiers, for a war that never stopped moving. He explained how German designers had become prisoners of their own perfection, obsessed with details, blind to the brutal logic of mass production. The Sherman, he said, had taught them humility. It wasn't the strongest. It wasn't the heaviest. But it was the one that always arrived. Across the Atlantic, American commanders were drawing the same conclusions. After-action reports from Normandy, the Ardennes, and Italy confirmed the same truth. Though the Sherman suffered in direct combat against heavier tanks, it always came back in greater numbers. The Allies could field 5 working Shermans for every German Tiger that broke down in transit. That was the true arithmetic of war. By war's end, over 49,000 Shermans had been built, serving in every theater, under every climate, on every front. They became the backbone not just of the American Army, but of dozens of Allied and post-war nations. The machine tested in secret by German hands at Kummersdorf had become a symbol of the industrial age, a weapon of endurance that won not through brilliance, but through resilience. And in the quiet halls of post-war design bureaus, those German engineers who once dismissed it would now borrow its lessons to shape the tanks of the Cold War. Because the war had ended, but its engineering truths had only just begun to unfold. When peace finally settled over Europe, the world's great armies faced a sobering realization. The age of mechanical grandeur was over. The future belonged to machines that could survive the war itself. In the ruins of Germany, the engineers who had once tested the Sherman were quietly recruited by both the Allies and the Soviets. Kummersdorf's archives were divided, some captured by American teams under Operation Paperclip, others seized by the Red Army. Among those documents were detailed performance charts of the Sherman's engine, drivetrain, and suspension endurance data, the same data that had once filled German officers with reluctant awe. To American analysts, the German notes were a mirror reflecting what they already believed: simplicity wins wars. To the Soviets, who had endured the endless mechanical failures of early T-34s, those same notes reinforced a core lesson: that a tank must keep moving no matter what. Within a few years, new tanks began to appear on both sides of the Iron Curtain, each one, in its own way, carrying the DNA of that wartime lesson. The American M26 Pershing, then the M46 Patton, inherited the Sherman's repairability and crew-friendly layout, but with the firepower needed for a modern battlefield. Across the Atlantic, West Germany's engineers, many of them the same men who had studied the Sherman at Kummersdorf, designed the Leopard Befern in the early 1960s. Its designers explicitly prioritized mobility, Maintainability and reliability over sheer armor thickness, a direct philosophical reversal from the days of the Tiger. In one interview decades later, a former Kummersdorf engineer confessed, "We realized too late that a tank must be a servant, not a monument." The Americans understood that in 1942. The Sherman had not been the best tank, but it had been the right tank for the kind of war the 20th century would continue to fight. Global, fast-moving and logistical in nature, even the Soviet Union, whose T-34 had shared the Sherman's philosophy of ruggedness, drew its own conclusions from the captured German reports. Their post-war designs, the T-54 and T-55, emphasized easy production, interchangeable parts, and the ability to fight after sustaining heavy damage. In essence, they followed the same mechanical truth that had once astonished the German engineers. Reliability is a weapon. The U.S. Army's Ordnance Department, meanwhile, turned the Sherman into a standard of comparison. Every future American tank, from the Patton to the Abrams, would be tested, not only for power and armor, but for how quickly a crew could repair it under battlefield conditions. The lineage of that thinking can still be traced today. When modern crews service an M1 Abrams in the field, swapping its turbine engine within hours, they are following the same logic born in the muddy fields of Kummersdorf. The belief that endurance, not elegance, decides wars. Yet for all its mechanical triumph, the Sherman also carried a quiet human legacy. Thousands of crews who fought in its steel hulls remembered it not as a perfect tank, but as a faithful one. It was easy to drive, forgiving to its operators, and, crucially, it gave them a chance to live through the fight. In an age when many machines turned against their own crews through failure or fire, the Sherman earned a kind of trust. German test engineers, too, had felt a version of that respect, an engineer's admiration for something that simply worked. In one post-war memoir recovered from the Bundesarchiv, a former Kummersdorf technician wrote, "We laughed at it first. We cursed its crude welds, its clumsy gearbox, but it never stopped. Even after we destroyed it, its spirit lingered. It taught us that war does not reward brilliance, only endurance." Those words, written years after the war, capture what no report could fully express. In the age of the Tiger and Panther, the Sherman had been dismissed as a mass-produced tool. But to those who studied it, fought it, and even feared it, it came to symbolize something greater: the industrial power of simplicity, and the quiet strength of reliability. And so, when the Cold War dawned and new tanks thundered across training fields in divided Germany, the echo of that old test at Kummersdorf still lingered, a reminder carved into steel and memory alike. The most powerful machine is not the one that shines the brightest, but the one that never stops running. In the quiet after the war, long after the smoke of Kummersdorf had cleared, one truth remained. Sometimes victory doesn't belong to the most powerful, but to the most persistent. The Sherman was never meant to be admired. It was meant to endure. Its armor cracked, its gun was outmatched, but it kept moving. Across deserts, through the snow of the Ardennes, over the ruins of Europe. It was a machine built on a simple promise, that a soldier's life depended not on perfection, but on trust, and trust, once earned, became the Sherman's greatest weapon. When the German engineers tested it, they didn't just measure steel or horsepower, they measured philosophy. What they found was not genius in design, but humility in purpose. Every bolt, every plate, every weld had been placed with one question in mind: will it work when it matters most? In that answer, they glimpsed something greater than engineering. They saw a reflection of endurance itself. Because war, in its cruel arithmetic, rewards not beauty, but reliability. The tank that starts in the morning, drives all day, and fights again tomorrow. That is the machine that wins empires and ends them. The Sherman taught that lesson to friend and foe alike. Its spirit lived on not in museums or monuments, but in the principles that shaped every armored vehicle since, from the battlefields of Korea to the deserts of Iraq. Even today, when modern engines roar with digital precision, the ghost of that old American tank still lingers, whispering the same quiet truth it once showed the German engineers at Kummersdorf, that in the end, survival is the highest form of strength, and reliability, humble, uncelebrated, often overlooked, is what carries both man and machine through the fire.